Hi, my name's Bruno. I've come here to talk obviously about J2ObjC. It's a Google project based around transpiling Java to Objective-C, so you can share code across Android and iOS for your development. So my background is I used to head up engineering on Google Earth and Enterprise Gmail, and so I've been out of Google for a couple of years doing VC, but I still enjoy programming. So you're my people here. So starting off with, when it comes to architecture, people love building twice. But although that works well for a building, it's not the very best thing that we could do for code. And with code, code duplication is generally a bad smell. It means that something is both, at the worst case, it's inefficient, and in the second case, that it's like an open invitation for bugs where you fix it in one place, of course the other place doesn't get fixed, and lots of problems that come with it. And so recently, Google actually published this just the end of last year, the new Inbox app. And it specifically shares 70% of the code across iOS, Android, and the web itself. The sharing Java across the web is obviously a familiar concept through Gwt, but the sharing code across iOS is something that's actually relatively new. And that there are a lot of systems that can be used, that have already been used to support this. I mean, for example, HTML5. The benefit, of course, with using Java is that you can get much more performant applications. You have much, you have much more extensive library support, and so. But in the case of J2ObjC, what they specifically focus on is all the business logic, and specifically avoid trying to translate the UI layer. And so the 30% that's not native is primarily user interface. So here's some of the other apps that have used it. They've got a bunch on their website. You can see more. And the funny thing about transpiles is that it usually thinks that you're making a spelling mistake. And so it's not actually that common to actually do translation like this. What they've done is that they've taken a Java runtime environment and basically tried to either do a custom implementation or as limited wrapper as possible around the iOS frameworks. So when it comes to using network access, many things like that, it will try and reuse the iOS APIs. So for example, I wrote a network time protocol client, a simple network time protocol client that actually gets the time over UDP using datagram packet in the Java library. And actually having done the port, it actually worked first time on iOS. Everything was translated through and there was no customization needed. It's exactly the same code across both platforms, which it works out wonderfully well. I say extensive but not complete, so there are certain things missing. For example, they're doing a lot of work at the moment on the security frameworks and SSL and so forth. And they want to be careful about that to make sure that they don't introduce any security holes or any problems. But other libraries work very well across it. JUnit, Mockito, Guava. There's a very strong focus actually around unit testing for the system. So the idea is that you develop the Java code, transpile it, along with all of the tests, and all of the tests pass. And that can give you a lot of confidence that both the system works, and every once in a while it'll actually give you some, you'll get to discover some kind of bug. And it's a rare bit of fun when you find a bug in the compiler, but that's essentially what this happens sometimes. So let me just sometimes Mac can be slow at starting up, actually. I don't know why that is, but it's an issue. There we go. Dun, 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 dun. There we go. So, and that's the URL at the bottom where you can read more about it. But it works very well. They advertise themselves as bug compatible. So if you've got a bug on your Android app, they'll give you the same bug on your iOS one. And of course, the converse is if you fix the bug on one, you fix it on the other. But as much as possible, they're trying to minimize surprises where you have code that's translated and doesn't work or isn't as performant. And in some cases, that the transpiled code can actually be higher performance on iOS because of there's no garbage collection, for example, that it has to worry about. So and it already talked about avoiding the UI layer. So this is the basic part of how it works. So you've got a file, hello.java. You call the J2ObjC command, and that will actually do the translation step. And this is what it outputs. And you can see in here the hello world that comes out the other end. It's not quite as readable, and because of the way that Objective-C doesn't handle there's like polymorphism with the different parameter types. So the types of the parameters are actually embedded in the method name. So it's not quite perfectly readable, but it does work. And from that, you then compile it. And of course, you get the perfect feedback in any Unix system, which is nothing. I sometimes think that there is like parallels to this in modern day life. That if you ever have somebody that's telling you stuff you either don't want to hear about or just I had an expression once. Somebody that I met had verbal diarrhea, and you really wanted them to act more like a Unix command. Just tell me when I need to know something, otherwise don't bother me. So from that, this step actually links in some of the other libraries for the JRE support, and then you can run the app, and of course it will actually output it. So if I actually do the now we get fun for a live demo. So we've got Hello Java in here, and so this is the release that's downloaded and shared locally. Actually, can you see okay? Actually, all right. I'll just do. I think that works. Okay, that's nice and big now. So you do J2ObjC hello Java, and it goes to think for a while, and then if I do here, this is the some contents of that it spits out, including the hello world, and there's a lot of other boilerplate that comes along with it, and of course the header file itself. Let me just do that. There we go. The header file as well, and it's, as you can see, it's a little bit difficult to parse, but the idea is that most of the time this is basically hidden, and the only Objective-C files that you care about is some of the header files where you're actually it's like a small interface boundary, so that you have to be very careful about what's your boundary between user interface and then the business logic, but that should be the only boundary that you need to look at. And then from that, do J2ObjC and then compile it. And that, of course, produces the hello. And then J2ObjC, and then I think it's -o. Oh, wait a minute. Sorry. Wait a minute. Did I get this right? Let's see. And then, and there it goes. And so what happened there is I linked in the JRE support and then ran the application in the Hello World class, and it came out with a result. And it's always a relief when it actually works. So back out to the presentation. So where I got involved actually is I've been working independently from outside of Google on doing a Gradle plugin for this. And the goal for this was to take something that is a little fiddly to set up and make it work extremely well for developers, everyone like you here. And in particular, we wanted something that worked well with Android Studio and IntelliJ, which is, of course, standardized around Gradle. And I'm particularly interested in something that's both efficient and also easy to use. Because what I've noticed from so many developer tools that I've used myself comes up, it sounds like a great system, you install it, you start playing around with it, and there's some obscure error message. And you're wondering, where the hell is that? And there may or may not be an answer on Stack Overflow, and then a day or two later it's like, okay, I'm just gonna write a bash script because that's what I need to do to get it done. And so having a good experience around that is something that I was trying to emphasize a great deal. So the plugin itself, we just released an alpha version. There's a couple of people working on it. So it's fresh out of the box just a couple of days ago. And a lot of development actively ongoing. So the main caveats you should know about it for the current state, J2ObjC, you can only do the end-to-end system on a Mac, which is not too surprising given that you're developing for iOS. The main thing that is a commitment about it was about the necessity for having a separate Java project that doesn't have Android dependencies. There is possible to be more flexible with this, but that's what we've chosen to start with. And when it means that it's you have a separate Java project, what it does is that it means that you've got that module should be the shared code that you reuse everywhere on all your different smartphone apps and also server-side as well. And so particularly if you're doing a lot of complexity around logic, for example, offline state or things like that, it's really hard to make that work when the logic is different at all those different points. But if you have a shared project, then it allows you to make it more complex and have more coordination across it. Some of the setup is not fully automated yet, and I would generally say it's in an alpha state. The reason I'd say it's in alpha state is that is mainly because of the user setup. So I want to have a good user setup experience. And as for the code itself, J2ObjC is actually pretty close to a 1.0 release. So if you get the whole thing to work end to end, I think it's actually good enough to use in production. But the standard that I'm going for is that it's really easy to use for a first-time developer. And that's where we need to do more work on it. So this is the main usage of it. So you have a project called Shared, and inside of that, the requirement is that you're using the standard Gradle Java plugin. And when you're using that plugin, you can change source sets, do any other funky stuff that you want, but it reuses all of the setting and configuration from that Java plugin. And the idea is, as much as possible, it just piggybacks off that. So you apply the Java plugin, you apply the J2ObjC plugin, and that would be the ideal thing. And it just spits out a library that you can, in the header files, and then link in link in Xcode. Now, it's not quite there yet. We need a couple more other lines, which is basically pointing to where your iOS app is and also the target that you want to update. So it's the target inside of Xcode. But as much as possible, that's what we're aiming to do. And then for the, sorry, I don't know, yeah. Sure, yeah, Bruno, yeah.
It's a simple observation, but couldn't you actually have split your approach into two plugins? One that actually generates Objective-C code that anything can use, and the other one that actually does the Xcode integration, so that basically you can automate generating the code on whatever system you want. Can be OS X, could also be Linux, and then the other plugin is run only on OS X to update.
So actually, so you're asking about splitting between tasks between the Objective-C generation and then also linking into Xcode. Those tasks are already split at the moment. And so you can actually use the plugin, for example, to do the translation step on a Windows machine. And one of the guys I'm working with, he really does not like using Xcode. And, and so it's a requirement for him that the tasks allow him to avoid stepping into Xcode as much as possible. And so the separation you're looking for, it's already there, and I'll describe it more in a moment. Yeah, no, quite right. For the Android project in your Gradle file, you've got the standard thing of the Android plugin, and then just have that depend on that shared project. And this is how you could separate out a Java library already. It just happens to have these other benefits for J2ObjC. So one caveat, right now we're working through an issue that we don't support the plugins syntax just yet, because there's some complexity in the plugins and how it links in with the Java tasks, but we hope to fix that soon. So this is basically the flow of order of the tasks, and you can just skip number 7, Renault, and you should be happy. There we go. So there's a pre-build step if you want to do anything special beforehand. For example, generating dynamic code. The cycle finder, this is more of an advanced use case. So because iOS doesn't have garbage collection, or particularly Objective-C doesn't, that the cycle finder does, it's very sophisticated, but what it does is it looks at the way that objects manage memory of other objects, and it passes through the whole abstract syntax tree of the entire, Java library, and then looks for something that might allow a cycle between objects. Now, as long as you don't have cycles, then the Objective-C method of it's like ARC. It actually doesn't use ARC, but what it does is, as long as you don't have a cycle, it can be confident that objects will be created and destroyed without them hanging around. And garbage collection is needed for when you have a cycle and need to identify it so you can eliminate it. But this basically, as you get into it, this is a way of just avoiding any problems with memory usage. So it's, for the most part, you don't have to worry about it, but it's an incredibly powerful tool. So the translate step, that was what I showed from the command line. Test is where it will take all of the Java plugin tests automatically with no configuration or whatever required. Create this text executable, run all of the tests, and then confirm that they all worked, that they all passed. And as a consequence of that, you can have a lot of confidence that the translation and compile worked exactly. I'm sure you had a question? All right, okay. So the build all the libraries, so this is what it does, is that at the moment this step is actually a little involved. What it does is it takes all of the Objective-C code and then J2ObjC is actually basically a small wrapper around Clang, Apple's compiler. And what it will do is it will generate all the different flavors. So debug and release, shared and static libraries, everything from ARM v7s to ARM64 and x86. So you can run it on the simulator, you can run it on new and old iPhone devices. All of those permutations will work. So as a consequence, it's doing a lot of stuff, but it covers all of the cases you care about. So the assemble is where it actually does packing. I'm sure if who of you have run LiPo, it does basically a fat binary. So with an Xcode, you just link to a debug or release library, and then within those libraries, it has all of the different architecture variants. And so it'll work across simulator to iPhone device. And then Rudin, this is where you cover your ears, okay? So the Xcode, this is one that's actually, it's working kind of okay. It still needs to be better, but basically designed to make the configuration much easier within Xcode. So it currently depends on CocoaPods, and the idea is that you install CocoaPods and it will set up the headers, the linkages, and other such stuff you need to get you started quicker. And those are all the tasks, and you can just obviously run a subset of them. This was, sorry. Okay.
I have a very basic question. You said you can use the .os basically and split those into Xcode and link the
Yes.
project with that. So how does debugging work in that case?
Okay, so the question was about how the debugging works. So once you spit out the object files, you link it and generate your .a file for Xcode, and that's what's linked in. And so for the debugging, it will actually allow you to step through the code because you set up, I think, ISIS root inside of Xcode, so it actually knows where the code is, and I can demonstrate it afterwards. So I can step through the code. It's not as what we haven't got working is setting up breakpoints and other things like that. So the system end-to-end works much better if you're doing your primary development in Java on Android, and then when the code goes over to iOS, you're generally assuming that the Java stuff is well behaved and that I'm making it beautiful, doing the great UI layer on top. So it's possible to step through it, and I've used that for debugging issues. But usually if an issue exists on iOS, usually that same issue exists on Android, and it is at the moment easier to debug on Android. Yeah. Does that answer your question? Okay. So this is basically the folder structure that generally suggest having. So your Workspace, Android app, and this one depends on the shared Java project. And then within the shared Java project, you apply the Java plugin, then J2ObjC, and down here you can actually include other jar libraries. And so as long as that jar library has got a source code with it, then that can actually be also compiled and translated and compiled as well. And then the standard source main Java. And then the build output, what it will do is most of the stuff you care about is in the J2ObjC outputs directory, and that's where it puts the headers and the library files for Xcode. And Xcode itself, the task will actually configure up the dependencies, and then hopefully it should all work. It's not quite there right now, but that's where we're going to get to. So along, oh yes, sorry.
Yeah. So go back to the last slide. The library, if the jar has sources, you mean it can use algorithm automatically find this from the repository just based on classifier review?
Yes. So for example, if you figure there is a lot of configuration possible within it. And so if you indicate in the, was like back here, the J2ObjC config, you can actually indicate that, okay, I want you to there's two ways of doing it. One is you can use build closure. And so as it pulls in other libraries and other code, then that whatever is pulled in by the Java plugin will also be used in the translation step. And that's one way to do it. Or you can explicitly enumerate to pull in certain libraries. What can be an issue, though, is that if the library doesn't have source code, then at the moment, if it's only got bytecode, at the moment that can't be translated. But that's something that we may end up supporting in the future.
So
Yeah.
if I understand correctly, it's going to be source-to-source generation, and so you can maybe just decompile it.
Yes. So at the moment, it's doing source-to-source translate as Java source to Objective-C source, but the plugin is trying to hide that as much as possible. So all you end up in Xcode is with a .a library and some header files. But did you have a specific concern about people decompiling, or?
No.
Yeah.
My concern is I might be having happen to use some third-party libraries.
Yes.
That have source.
Yes.
Or have source I don't want to decompile every time.
Yeah.
And so maybe just have something to deal with bytecode only.
So there is an alternative system. I think it's RoboVM that allows a translation of bytecode. It can go from bytecode into essentially the Dalvik bytecode for Android. No, wait a minute. Sorry, the other way around. It goes from the Java bytecode into ARM instructions, so it may be that we support something like that in the future. That would come from the J2ObjC team at Google if they choose to do that. But there isn't the trade-off with RoboVM is partly in terms of performance, and also because when you're doing bytecode to machine code, it's hard to know exactly what's going on underneath you. Whereas with the source code, you can be, because it's a higher level concept, you can get much better performance and I think actually compatibility as well, actually. So we don't have a perfect model. If you don't have source, we don't have a good story about that yet, but potentially in the future. Yeah. Does that answer the question? Yeah. Okay. All right. So this is basically the suggested structure, and I think that if you choose to use a system like this, most of the work is actually in separating the Java code from the Android project into this shared project, because it's very easy to have a lot of dependencies within Android, but it's also that separation is actually generally a pretty good engineering practice as well, because you're separating in your model view controller paradigm, you're separating your model out from the user interface. And so there's benefits that you get aside from just being able to use the translation. So one of the things we spend time on is helpful error messages. Do anyone know what exit value 139 is? So this is what try and actually present as an alternative is this is a segmentation fault in user space, and by analyzing the output from the test, we can identify that Mosquito spy can actually be a cause of this, and so we actually put up a helpful message saying, okay, this is what might be the issue, and therefore this is the process to go and confirm that, fix it, and then watch the bug if you care about it. And so we don't do it everywhere, but as much as possible, we've designed it to actually have helpful messages as opposed to, the obscure ones where you're wondering what the hell is going on. So future plans actually we've got to improve the quality, and particularly as we get more contributions to it, adding on unit testing of the plugin itself, example project. We've got lots of, we've got a lot of bugs already, but general devastation in that area is a good thing. Integration with Xcode. Singular is, for those of you who know Angular as a sort of like a web framework, Singular is a project that's going to come out of Google. They've talked a bit about publicly but haven't released, where they're taking the Angular-like paradigm and bringing it to Android development, and I think that this actually could have a very interesting story for working with J2ObjC. And the ideal scenario is that as a designer, you might only need to work in developing user interface and tagging it with the right annotations and names, and not do any hookups to code at all, because it can be automatically generated. And so I don't know if we'll get there, but the ideal point would be you have a designer working in Android Studio and another designer in Interface Builder and Xcode, and they can set up all the UI that they like, and as long as they configure it correctly, they don't have to write any code, and everything will magically link together, and unicorn babies will be the result. And so we'll see if that happens. When we get more feedback, beta and 1.0 releases. And so that was it for the main presentation. So I was just going to look at show you the code actually, since we are actually at a developer conference, we can't get away from that. I apologize, no pictures of Snoopy or Borat here. Actually, I wondered about slipping in some ASCII art for each of them, but it's actually, I try and keep my ASCII art to the folder structure instead. Anyway, so first thing actually I'd like to identify is all the contributors. So it's Adve, a guy I worked with at Google, Michael Gorski out of Germany, and Peter and Sterling from Gradleware. It's Peter and Sterling from Gradle themselves. Peter's no longer there, but Sterling was, but both of them been a fantastic help, actually, and the engagement of Gradle has been great with the external community, so very grateful for them for that. So the main part of the plugin happens here. So what you're doing is during the apply step, it creates, helpful message if you don't have the Java plugin. And then what it will do is it will create all the different tasks, set up the dependencies between them, and then the tasks themselves are designed to be fairly self-contained, and all of them use input and output so that they up-to-date checks all work correctly. You run the same thing twice, then it will take Gradle 2.4 is so much faster, and just being able to know in 2 seconds flat that nothing's changed, great, that's fantastic. And I'd say generally it's pretty well engineered. Going through code review, it's on GitHub. It's changed a lot over the last few weeks, but it's been going on for a number of months. Yeah.
I can't quite tell, but you're probably going to have to port this to the new Gradle model.
Yes. So that one actually was very interesting to me. There's some benefits for us doing that because we create actually quite a lot of hidden tasks for compiling all the different library variants. And then also I know that from running the command line from Workspace that it has to go and check a bunch of build Gradle files to see have they updated at all. Yeah. And so that's something that we will adapt to that then. Yeah. Yes. And then the main thing in here is the extension. So these are all the configuration stuff you can do, and there's quite a lot of them. These are the standard libraries that it will actually do the translation with, and you can add to that if needed, and tries to use it be fairly Gradle in how it works and operates. And the result of that, I mean, I've been using it for personal app development for quite some time now, very, very happily. And like doing the simple network time protocol, that's something beyond just business logic, because there's network connectivity in there, it's running on a separate thread, and it all works. And it's one of those projects, actually, even inside of Google, that there was quite a lot of doubt inside of Google about, would this thing actually work at all? And to actually get through, compile something, run it, and finds out, yeah, it actually works, I thought was great. And so we want to just do a lot to make it much easier to do. So anyway, that finished the main part of the talk, and happy to take questions.
How the hell did you abstract going from the Java network layer to the Objective-C network layer?
So that's the magic, Bruno, and I'm glad that you see that. So that's why they doubted whether this project would work at all.
That's why I doubted myself. If you did that, holy hell.
Well, so that's not something I can claim credit for. The two guys that did it are Tom Ball and Keith Stanger out of Google, and I am in awe of what they've done. And that I was shocked that it worked, and I was even more shocked when it actually worked first time. And because I did this simple network time protocol client, and it's an adaptation of the code within the Android open source project with some other stuff that I wanted to get in there, and the thing worked. And so they very carefully looked at the JRE and decided, okay, how can we re-implement that using either something written ourselves or a wrapper around the Objective-C and iPhone SDK. Now, where this is really going to get interesting is when they get into security stuff and SSL, because they make that work, and it'll be even more impressive to me. But those are guys that I think can actually do it. Yeah. So, as I told you, unicorn babies, So, happy to answer other questions, or I could just afterwards I can show some of the stuff I'm working on, and I can show you the build and all it works. I haven't got a great demo for that to share, but I promise you it all does work. Yeah. So, any more questions then? Yeah.
So for those tasks, are they because I don't know the translator and also some other stuff implemented in what language, and invoking those binary executables, or you just call out to some, for example, if it's Java, then with the plugin you can just call it Java. Just curious.
Sorry, I didn't quite understand the question.
For example, translating the Java.
Yeah.
So this is a plugin. This is the Gradle plugin.
Yes.
How the Gradle plugin invokes that translator?
Right. So what it does is that inside of the translate task here, this is the command that actually does it. It's a project exec. So if I actually go do, sorry, yeah.
So basically you're invoking that binary.
Yeah. So basically what it does is that it invokes J2ObjC, what I just showed on the command line demo, and then there's some funkiness in there about if you really want to do translation on Windows. And there was some guy that asked for that, so we added it in, and it works. And so all of the complexity of this method is to set up the right arguments to that command. And as you look up here, there's a lot of different inputs about whether they're dynamically generated files, whether you've got additional classes you want to do, because because Xcode has, you can't include nested directories easily. Turns out that if you actually wanted to take the source code into Xcode and then work with it there, and that's something I think we may actually end up supporting as well. We've had it working in the past, so you can make the debugging like a perfect experience. Then, we can support that as well. But, all of it down here, this is all to basically make it, a nicer experience. So if you have an error, it'll output what happened, and if we see an error that we recognize, or see an error that we recognize, then we pull that out and make it more obvious to you. But yeah, it's a lot of mapping to make those commands easy to run. All right. Okay, I think that. But thanks very much for all coming. I hope you found it helpful. And the best place to actually let me just put up the last thing. Where did I actually do this? Okay. I don't actually think I had it on the. Yeah. So what we should do is that one's there as the link, and if you follow that one, you'll find there's a link on that page to the Gradle plugin, which will take you over to our GitHub project. So actually, what I can just do, it's J2ObjC contrib, and yeah. So, dun 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 dun. All right. I'm just going to delete all of that. There we go. Then it works. Let me just make sure. Does that actually work? I'm able to type URLs. That's great news. So those are the two files. So the second one is the plugin. The first one is J2ObjC itself. And so you can mainly that's useful for the documentation because it describes how you can use them. And very interested in co-contributions or feedback. And so we're developing it open source, and it's going through quite a bit of iteration. So if you do encounter a bug, message us, and then we'll fix it. We'll fix it promptly for you. But thanks very much for coming, and I hope this is helpful for you. Thank you.